everyone! In this video, we'll solve some problems of principles of hydrostatics in the fluid mechanics. A closed 5-meter tall tank is filled with water to a depth of 4 meters. The top portion of the tank is filled with air which, as indicated by a pressure gauge, at the top of the tank is at a pressure of 20 kilopascals. Determine the pressure that the water exerts on the bottom of the tank. So in the problem, let's identify first the given. So we have here the 5 meter as the height of our tank. And we have here 4 meter as the depth of water in our tank. And we have here 20 kilopascals as our pressure at the surface. So in the problem, we are asked to find the pressure that the water exerts on the bottom of the tank. So we are given a top closed tank, which implies that the bottom pressure is not only dependent on the pressure at the water column, but also it will depend on the pressure exerted on the free surface. So the pressure exerted by the water at the bottom of the tank is the sum of the pressure on the water surface and the pressure due to the water column. So we have this formula in finding the pressure at the bottom of the tank. The P bottom is equals to the specific weight times height plus the surface pressure. And we know that the specific weight of water is given as 9.81 kilonewton per cubic meter. So plugging the value in this equation, we will now have 9.81 kilonewton per cubic meter, wherein our specific weight of water, since this is in kilonewton per cubic meter, we need to express this in newton per cubic meter by multiplying 1000 newton over 1 kilonewton. And also our height of the water is 4 meter, plus the surface pressure, which is 20 kilopascals. And since this is in kilopascals, we need to express this in pascals. So we will multiply 1000 pascals over 1 kilopascals. So plugging this in calculator, this will yield into 59,240 pascals. So now let's convert this 59,240 pascals into kilopascals by multiplying this to 1 kilopascals over 1000 pascals. So this pascal now will be cancelled, and therefore the pressure that the water exerts on the bottom of the tank is 59.24 kilopascals.